Okay, so mostly young women, white, no colored people, let's say. Now, please replace the professional by the term unprofessional, so unprofessional female. And please tell the audience again what you observe.
So it's mostly colored people with afro hair. Yeah.
Yeah, exactly. So thank you for the nice intro to my talk. Basically, this is what my talk is about. It's about bias. So what you observe here is called interaction bias. Basically, by querying Google with these terms like professional female, unprofessional female, and clicking on the images, we teach the machine somehow what is a professional female, what is an unprofessional female, and obviously here we have a kind of a discrimination, let's say. Now, you know, we are surrounded by these kind of machines, like search engines, recommenders. Let's say you click on a recommendation for a film on Netflix, or even you click on an article based on a recommendation on the online Tagesanzeiger platform. So we are all surrounded by those machines, and I hope you come along with me that it's quite important to understand how these machines works as a consumer, but also as a designer to be aware of all the possible pitfalls regarding this problem with bias in algorithms. But even though we have more machines in more sensitive fields like in medicine or even predictive policing, if you heard about it, even here in Switzerland, Zurich, Solothurn and Basel, they already experimented with this kind of systems, and probably many people on the street, they don't know that the police is working with such systems, and these systems as well, they are prone to bias. So here is another one. In the late 80s in London, quite a famous hospital decided to basically to optimize their HR process, so the process to hire people, and they basically wanted to have a machine which was able to pre-select promising candidates for a specific job. So they worked together with the university, they hired a bunch of nerds and designed, implemented and deployed in production such a machine. And after half a year, let's say 8 months, they did an assessment to figure out what was the benefit now of this machine. Did it really somehow made the hiring process more efficient by letting the machine pre-select candidates which could be promising for a specific job? And they figured out that the machine works, but there were also problems. They observed that the machine almost never proposed females or foreigners to go to the next step in the hiring process. And of course, people started to blame the machine then, because they said, okay, this machine is not working, it's poorly designed, that does not pay off. Then people basically had a second look to better understand what's going on. And what they figured out was that basically the machine did exactly what people before did. People in charge to hire people. So these people discriminated basically women and discriminated foreigners. They didn't propose them to go to the next step in the hiring process compared to what could be expected from the data. And to better understand how this can happen and where are the doors where this bias can sneak in a machine, we have to, let's say, formalize a bit things. We have to talk a bit about how those machines are trained and the whole process from gathering the data to to the result. So please, for the next minutes, be a bit patient. I will show you some fancy diagrams. Of course, I did this because I wanted to do that in LaTeX. So, but yeah, so we need to do that to proceed in the discussion afterwards when I jump again more to a storytelling mode. So basically, we start with something very simple. We start with reality. Reality is quite simple, right? At least in the context we are discussing this here. So we stick on the example of this hospital. So you can think about the reality here that you have job applicants with specific attributes, characteristics, and these attributes and characteristics basically they determine to some extent if somebody is able to do a job. Now, are there any HR people here in the audience? Raise your hand. Okay. So probably these guys will tell you that they exactly know what these attributes are. They tell you that, yeah, we from experience, we know what are the characteristics we have to look at to figure out if a job applicant is suitable for a specific job or not. Now, the truth is they don't know. So nobody knows. So it's an illusion that they know. Basically, what they do is, what HR people are doing is, they try to guess what are these attributes. And in an abstract sense, basically, you can understand this as a measurement. That means that you have an interview and you ask specific questions because you think that the answer gives you an indication if somebody is able to do a job or not in a satisfactory way. And you persist those answers in data, or you scan a CV by a machine and you extract some features of the CV or some information of the CV, and you persist again this information as data. So there is a chain from reality, let's say, to the data points you are using then to train such a machine. And already here you have a lot of opportunities for bias to sneak into the system because somebody has to decide what are the relevant attributes. What are the correct attributes to describe if somebody is able to do a good job or not? And so basically, this kind of selection can lead to a huge selection bias because if you choose the wrong attributes to measure, let's say, that causes then problems when you basically want to train a machine based on those data. So this transition from reality to data is very complex at the end, and people very often do not take enough care to think about what they are measuring, what attributes really are relevant for the problem to solve. Okay, because it's very common that you are under time pressure, you have to deliver something, so you try to aggregate data as fast as possible, but you can do a lot of mistakes leading to huge biases, as I will show a bit later. Now, from the data, basically, what you do to have a machine in place, as I described, to do a pre-selection of promising candidates from a huge pool of possible candidates, you train a model. So you teach basically a machine that learns a correspondence or correlation between the attributes you measured and basically the probability that this and this attribute will lead to a successful application. Okay? So basically what you're doing, you map the data in a so-called decision space, and the decision space in that example would just be numbers, probabilities that a candidate is worth to go to the next round in the hiring process. Now, if you have this result in the decision space, you can basically compare with an appropriate metric how accurate was your prediction. But this measure how accurate your prediction is when you teach a machine always happens on the past data. Of course, you can never test the machine when you design it on future data, unless you are, to come back to physics, unless you are a tachyon, which can move faster than the speed of light, and you can go backward in time, but then you have an imaginary mass which causes other problems, of course. So that's another story. So you are basically forced to measure the quality of your system at first place always on past data. So predictive systems are always trained on past data, evaluated on past data. And that's also very important to understand, because if the world fundamentally changes for some reason in near future, your machine will basically produce useless results because it was trained on another reality given by the data you feed into the machine. Okay? Now, this step here as well has huge potential to introduce bias. One is called latent bias. It means that the machine tries to find a correlation between, we call it a protected variable, like the gender and the success rate, for example, that the applicant gets the job. Okay? But this correlation is useless, because you won't basically build your hiring process based on if somebody is male or female, and then decide, yes, because it's a female, it's a woman, I will not hire her, given the skills she has. But if basically this happened in the past and the machine learned from the data which were gathered in the past, of course the machine will take this pattern and amplify this pattern. Now, as I said at the beginning, you cannot know these attributes, the real attributes, but you can guess them. And why should this chain, so reality to data to decision space, why should this chain basically work at all? I mean, that's a good question. Why should it work at all? So the hope here is always that if basically you knew this map from the reality directly to the decision space, we don't know. But if you knew that, then you hope basically that if you have two data points in the reality and you could map them directly to the decision space, that these points are nearby as well if you go the other way of the chain. So what you hope basically is that by applying this map, by measuring attributes, teaching a model, assess the quality of the model and so on, you hope that you do not a too big error, okay, compared to what really what really happens in reality. So, as I said, you have this chain basically opens already the door to introduce some kind of bias or discrimination, as we have seen in the first example I gave you. Now, I put a red box here around because one thing to mention, it's quite important, is that when people talk about algorithms and systems and talk about even, they call it artificial intelligence, but when people talk about that and regarding to bias, basically, they talk always just about this X to Y space. So they think about how can I make my model better, more accurate, and so on. But they seldomly think about the whole chain. So how can basically I increase the quality of my measurement to get the data, which is even much more important than how you would train the data. So basically what this red box tells you is that whatever algorithm, whatever method you use to accomplish a task, you have basically to see that always in the context. So it's not basically that you can teach a machine take the machine and put the machine in a completely different context. If you do that, probably you trigger a disaster in terms of bias, because all these algorithms, all these methods, they are always trained on specific data in a specific context, and it's very important to keep this in mind always. Good. So that's why here is written context. Context is king. So it means that your algorithms never can be viewed isolated, or yeah, they are always embedded in a very specific context. Now, just to finish this formalization thing, you might ask, okay, how can I measure if something is biased in my model? Or probably you think, okay, how can I measure if a algorithm is fair or not? And one measurement or one quality attribute to quantify this basically is called opportunity of equality, and it tells you that if you have a protected variable like male and female, what you want, let's say in the example of classified job applicants, what you want is that the classifier or the system behaves similarly for female and male. And you can formalize this by this formula here, which tells you that what you want is that the probability that a female, in the example here, gets a chance to go to the next step should be exactly like the probability that a male gets the chance, so that basically the system works the same on both classes, male and female. Okay. Now you may say, okay, if it's so easy to basically formalize this problem here regarding fairness, why don't people do it? So why don't we just remove the bias? Because basically it's possible if you spot a bias like that I explained you, that you remove it, so in the system. Why don't people do that? Why don't organizations do that? The problem is that it's very hard to spot them at the end. So you have to think first about what are your protected variables, what you want to basically measure if something is biased or not. And this takes time, it's costly, and there is no force or there is no reason or no pressure that organizations are forced to think about in that direction. So people basically, they are consumers of all these kind of systems, and many of them, they already have a bias in, and nobody basically is responsible, or it's very hard for you as well to go to Tamedia and basically ask to, let's say, to get the insight and explained and basically outlines that what we do is correct in terms of bias and discrimination as well. I give you an example from an ongoing project we are doing right now, right after that slide. So sometimes basically you may say, okay, now I have the potential to remove those biases and I want to do that. That's really a nice goal, but it turns out that sometimes for specific tasks, the bias basically is the trigger that a specific machine to accomplish a specific task works good. So if you remove the bias, then sometimes it does not work as well as if with the bias. And I give you, basically I want to give you an example now. So basically we are working right now, together with Barnaby Skinner, Tim Nonner and others on a project, on a DNI Google project, which is called Comment View. And this project basically has, let's say, two main goals. So one goal is to improve the comment ecosystem as a whole. That means that we try basically to give the user a better experience to make comments on articles we try to give the user a better overview that he can basically decide easier if he wants to participate in a discussion or not. And the second goal, the second main goal of this project is that we can reduce the workload for reviewers. So if somebody comments on a Tagesanzeiger article, the comment is not available right after you hit the submit button, but the comment will be reviewed by a human, because we cannot publish all the comments, of course. You can imagine that you have many comments which are not suitable to publish on the platform. So there are reviewers, they are looking at these comments, and they decide, yes, I'm able to publish it, or I'm not allowed to publish it. So the idea is basically to design a machine which significantly reduces the workload for those humans, because then those humans are able to do their job better, because they can focus on less volume and increase the quality of the review in that way. So the overall goal was to reduce the overall goal is to reduce the volume by at least 30%. So here we are on a good way. So the classifier now is in production as a test, and reviewers can see what the machine decides, and then at the end we will compare how accurate basically could the machine discriminate toxic versus non-toxic comments. So, but this is not the thing here. I just wanted to give you some context. But then what we did, we wanted to better understand, okay, is there any bias, or are there patterns which you could label as stereotypes in the model between, let's say, terms, specific terms, and protected variables. And we did some experiments, and we have chosen as protected variables male politician and female politician. And what we did basically, we measured to some extent how strong a specified set of terms is associated with male politicians and female politicians. And the corpus for the training for that model, again for the discrimination, was based on past comments. So we had basically 700,000 comments where we trained this model. And what you can see here now is basically some stereotypes imprinted in the model, so patterns that the model learned, and some, let's say, some discriminating elements. So if you look at, so the green ones are basically the male politicians, and the female are the red ones. Now, basically the set of terms you have on the x-axis then mapped to these bars gives you how strong is an association of a specific term with a male politician or female politician. And what you can observe, for example, is that female politicians are much more associated with Kindererziehung und Sex and less with Parliament and Bundesrat. So what you see here is some stereotypes you also observe in our society, of course. And this has some discriminating, let's say, elements in it, right? Now, you can say, okay, we spotted this. I mean, this is a kind of bias, if you want. So it shouldn't be that way. It should be that these bars, they all have about the same height and are slightly scattered around the zero, the flat line. Then you could say, okay, my classifier or my system is about neutral. The thing is that you can basically debias the system by calculating the bias, and you remove it from the model. But then the model does not work as well with compared to with the bias. So we don't remove this bias here because the model works much better with this bias. So with these discriminating elements at the end. So why? Because somehow it reflects more what happens in reality, right? What happens basically, or what is the universe of commenters we have on the online Tagesanzeiger? It is a fact that females are much more bashed compared to male politicians. We also published together with Barnaby Skinner an article in the Tagesanzeiger about that. So Miss Somaruga, for example, is one of the most hated person in all the 700,000 comments we had for the machine to train. So the point here is, and that's why the context is so important. Basically, you could take this model and you could take it to another context. For example, you could take the model to evaluate is an article written by a journalist positive or negative. If you just would take this model and do that, what you would observe is that when a journalist is writing about female politicians, then the model would a priori label that article as low quality. Because the model basically learned that if female politicians appear in the text somewhere in a specific context, that this text is not worth to publish. Okay, so you see, you cannot just take out a model somewhere and put it in another context. That's very important. That's why I basically put the red box around this system. So you have to rethink about what the model is doing. You have to retrain the model on new data. And it's not that easy that you just take something and put it somewhere else and it will work perfectly as well. So what you can do here, you can remove the bias, that's true, and then you can probably transfer the model to another domain, which will work. So basically we plan to do more investigation in this direction because this gives some really nice insights how people basically react on articles by commenting on them. Okay, so the whole thing with bias and algorithms, that matters. That matters because these decisions done by machines, they influence our daily life to some extent, right? And nobody basically regulates how this machine should work. Nobody, there are no standards, let's say. It's not a standard where you can say, okay, I tested this machine according to criteria A, B, C, and D, and these are my results. And the consumer, for example, is able to get these results. And it's like there is no TÜV for algorithms, right? So no standards in that way. There is also not enough awareness, let's say, for this problem. So people are not really aware that how they are influenced, let's say, by these algorithms, how decisions are influenced by those algorithms. There are many examples, mainly also from US, where these kind of algorithms help in the area of law, for example, to make decisions. So we need a bit more of awareness of that problem. We need a bit more publicity of that problem, and that's why I'm very happy that journalists at the Tagesanzeiger, they are also motivated to write then and when about algorithms and bias and stuff like that. In the research community, there something is happening. So in the last 2-3 years, basically, there were many research groups newly founded, let's say, taking care of all these problems. There is a long way to go to better understand what's going on here. Then, as I said, there are no standards. That's quite a problem because everybody can do what he wants. I mean, organizations like Google now, they announced they have an AI ethic board, and I mean that's ridiculous. I mean, it's good they have it, but I mean, yes, so what? I mean, if a tech giant basically give a statement that they have their own ethics. What does it mean? I mean, this is a societal problem to some extent, so everybody should be able to discuss around this topic, and this cannot be a problem which is just left to tech companies. That's for sure not the right way to do it. Then the question is if for some sensitive applications, if there are regulations needed. So politics basically has to discuss this as well. And I'm sure in the next 3 to 5 years, this will become a topic in politics as well. I mean, it doesn't mean that that they forbid research in that area, which is basically not possible, but probably for some sensitive applications, like also in medicine, we need some standards. And you as a consumer, you can ask to see the certificate. It's possible, at least in principle, that you understand how such a machine was tested and what is the quality of that machine. And probably the most important one is education. So I have 2 sons. Okay, they are they are quite big now. So the bigger one basically is now 22, and when he had in the school basically they had this Informatikunterricht, and when I asked what do you do in the Informatikunterricht, he says we learn how to open Word and Excel. I mean, come on, that's ridiculous. These guys, they know how to do it. So it's much more important to talk with these people, with these teenagers, with these young people about what is the impact of all these machines. And you can integrate basically all these topics in mathematics or in history. I mean, today it's very important to know that somebody 20,000 years ago painted some stuff on a wall somewhere. But basically, people are not educated. What are the impacts of these technologies? How do they work, and so on? So I think that's very, very important to have a better education in that regard. Yeah, so that's it basically, and I hope you had a small insight here about topic of bias in algorithms. And what I want to mention is that in this comment view project, we are really eager to learn how these models, how this system basically incorporate these kind of patterns to better understand what we are doing here. That's it.